There are about 2.1 billion people globally do not have access to clean, safe drinking water. 3.4 million people die each year from scarce and contaminated water sources. Millions of women and children spend 3 to 6 hours each day collecting water from distant and polluted sources. The time it takes to walk the average 3.7 miles for clean water is time not spent generating income, caring for family members, or attending school. At any given time, half of the world's hospital beds are occupied by patients suffering from diseases associated with lack of access to clean water. The problems to the access of clean water and sanitation are due to people living either in non-service and degraded parts of urban centers or in rural communities across the globe. Safe drinking water is hard to find, and for example, water is free from contaminants using treatment are not available. And next, intensified raw wastewater discharges along with higher volumes of surfaces contaminated are runoff. Climate change and population growth will further exacerbate the problem. Water pollution and halving the proportion of untreated wastewater are increasing in undeveloped countries. Next, also, water use efficiency across all sectors to address water scarcity is very low. The design of water conveyance, distribution, and processing system and change in the use of water in agriculture are not improvised. As per early hypothesis, water and sanitation can be achieved by using natural resources. In this project, students have done the experiment by running a simulation to filter dirty water. Students have used big rocks, pebbles, sand, and cotton to filter water. Students also built a 4 level of water filter by placing each of elements in each cup. This level have succeed filter the dirty water, and as the result can be seen in the video on next. The results are also explained in the results section. Other than that, plastic water, plastic bag, or inner tube can be used. Besides, elements such as charcoal and clean cloths can be used as a substitution of cotton. By spreading the awareness of clean water, the community will be more careful in choosing water for them to drink and care about the cleanliness of water they will use. Therefore, diseases such as cholera, diarrhea, hepatitis, or polio that link to contaminated water and poor sanitation can be avoided. As the result of good water filtration, people spend less time and effort physically collecting water when it comes from improved and more accessible sources, allowing them to be more productive in other ways. By eliminating the need for lengthy or dangerous trek to collect and carry water, this can also increase personal safety and decrease musculoskeletal disorder.
Next is our non-engineering solutions. First, prepare 5 different cups to hold each filters. And then, to every cup, we will cut a hole. After cutting the hole, we also cut the straws into pieces and then put it into every cup. After done with that, we will use the hot glue gun to glue and secure the straw on the cup. After done with gluing, this is how our water purification system supposed to be like. Next, for the first cup, we will fill big stones in which to remove large impurities such as leaves or clay. For the second cup, we will fill it with small pebbles to remove smaller impurities such as insects or dirt. And third, we will use sand to remove fine impurities. Lastly, the cotton to filter and produce clean water for the result. So next, we're gonna try our water purification by inserting dirty water into the system. After a few seconds, the filter will be filled and the result will come out. Hence, this is our clean water and the goal is achieved. My name is Animuzuddin bin Adik Musapa and now I'm going to explain engineering solution for clean water sanitation system. So for this goal to achieve, we will use RO, reverse osmosis system, to provide us with clean water. So from number 1, which is the feed water from the cold water supply, we move into the first stage, which is the sand filters. Second filter is the carbon, and the third one is the water smoother filter. From all those 3 stages, they will go to the pressure valve. From the pressure valve, the water will flow in very high pressure into the membrane. The membrane will work to eliminate all the dissolved substances, and then from the RO membrane housing, there comes a clean water. Either you want it to go to the drain or post carbon, which will make the water drinkable, to the faucet or to the storage tank in our house. Hence, this is the engineering solution for clean water and sanitation.
In conclusion, we all deserve to live in a world where everyone has access to clean running water and sanitation. Our freshwater ecosystems are safeguarded for the future. Water is our most precious resource. It sustains life everywhere, and we all have a role to play in helping the UN achieve this goal by the year 2030. In summary, sustainable management of resources and access safe water and sanitation are essential for unlocking economic growth and productivity and provide significant leverage for existing investment in health and education. That's all from us. Thank you.